Hello, Ms. Low. We are from class DAPC 2A1, Group 1. Me, Haisin, Raphael, and Shane will be presenting our water filtration system from Experiment 4. Firstly, I'll be presenting our water filtration system's design. The materials we used include a plastic water bottle, activated charcoal left over from an aquarium, sand, two types of gravel, one with size 1 to 3 millimeters, and the other with size 3 to 6 millimeters. Hair nets, a soup bag, cotton pads, surgical masks, and rubber bands, which have all been provided by the lab. We also brought some HOCl to experiment with its effects on water. The water filter consists of 6 major layers, each decreasing in the particle size it can filter. The first layer is the activated charcoal, crushed slightly to form smaller pieces and placed into a soup bag to allow the charcoal to be easily removed later on. The second and third layer consists of 3 to 6 mm gravel and 1 to 3 mm gravel respectively. The gravels are wrapped into their own individual hair nets to allow them to be easily separated. The fourth layer is the fine sand followed by cotton pads in the fifth layer. Our sixth layer in the water filter initially consisted of 4 layers of surgical masks before we removed 3 layers for further experimentation. The estimated weight of our water filtration system is around 330 grams. The activated carbon is added to remove impurities and contaminants. It also aids in the removal of color and odor in the water. The gravel, sand, and cotton pads were used to filter out large particles from the water to allow smoother filtration through the finer filters. The surgical masks are rated to filter particles larger than 0.1 microns. 4 layers were added to enhance the filtration of the water. The HOCl added is used to kill or inactivate microorganisms, making the water drinkable. The pH of the filter water is also slightly lowered after adding it.
I will now be talking about the efficiency of the system. Materials were arranged largest at the top whilst the finest were at the bottom. This ensures that larger sediments are trapped closer to the surface while smaller sediments are trapped at the lower levels. This prevents the initial clogging of the system as sediments are less likely to clump up at one single level of filtration. Natural materials like sand, rocks, and carbon also help to attract and remove impurities like bacteria and debris, increasing the water's clarity and lowering levels of unsafe materials. It took 35 minutes to obtain that amount of water, thus it has a filtration rate of 2.86 ml per minute. The water obtained is very clear, thus possessing a score of 1 on the clarity scale and only 3.75 nephelometric turbidity units. It was observed that not all the water initially added had filtered out of the system and can be concluded that despite the low filtration rate, very good results were obtained, that is within the range of drinkable water. In filtration number 2, we instead used a single layer of masks instead of the initial 4. We added 100 ml of water and collected 50 ml in 7 minutes and 15 seconds. This gives a filtration rate of 6.90 ml per minute. The water obtained is still clear but has slight debris, thus obtaining a score of 2 on the clarity scale and can be supported by the result of 40.8 nephelometric turbidity units. It can be observed that the filtration rate is slightly increased, but that is at the expense for less filtered and more turbid water.
Thank you, Raphael. I'll be presenting the areas of improvement. How to reduce color? The color of water is caused by different organic compounds in it. Activated carbon can be used to reduce color. It contains a large surface area and can absorb the organic compounds when the water passes through the layer of activated carbon. We did use activated carbon for filtration, but the water is still not drinkable. We can improve this by increasing the surface area of the activated carbon by crushing it into smaller pieces, so that more organic carbons can be absorbed and the color of water improves. Next, how to reduce conductivity? Conductivity of water is related to the total dissolved solids and hardness of water. Lime and soda ash can reduce the hardness of water. Lime is used to remove carbonate hardness and soda ash is used to remove non-carbonate hardness. When lime and soda ash is used, hardness-causing materials form nearly insoluble precipitates such as calcium carbonate and magnesium hydroxide. Then they can be removed by filtration, thus reducing conductivity as hardness decreases to an extent. How to reduce alkalinity? Alkalinity is measured in the unit milligrams per liter of calcium carbonate. Alkalinity is affected by the presence of hydroxide ions, carbonates, and bicarbonates. The addition of vinegar which contains acid can reduce alkalinity. Vinegars will react with the OH ions, carbonates, and bicarbonates present to reduce the alkalinity of water. How to increase the speed of filtration? Firstly, perform sedimentation before filter starts. The solid particles will sink to the bottom of the beaker, and when water is poured into the filter, there will be lesser solid particles at first, and this prevents the filter from clogging. Secondly, wash the filter media. This is to remove the solid particles trapped by the filter media so that there will be no clogging. Lastly, remove one layer of mask instead of three. When three is removed, the turbidity increases drastically. So, we need to take a balance between turbidity and speed. Therefore, only one layer of mask should be removed to ensure that the water is clear and filtration rate is relatively fast compared to previous filtration. Now, I will pass my time to Shane.
So the chemical test used is color, turbidity, conductivity, pH, and alkalinity. Firstly, color test. So the results before the filtration is more than 500 PCU, and the results after is 91 PCU. The apparatus is a water meter, and it measures adsorbents by using an optical system that uses LEDs, narrow band interference filters, focusing lenses, and both a silicon photodetector for adsorbance measurement, and a reference detector to maintain a consistent light source. Color is mainly affected by the presence of minerals. Secondly, turbidity test. The results before the filtration is 253 NTU, and the results after the filtration is 3.75 NTU. The apparatus is a turbidity meter, and it works by shining a light into the water and measures how quickly the light is scattered by the particles in the water. Turbidity is affected by water color, chlorophyll, and total suspended solids. Next, conductivity test. The results before the filtration is 1850 microsiemens per centimeter, and the results after the filtration is 1730 microsiemens per centimeter. Conductivity measures how easily electricity flows through water. The apparatus is a conductivity meter. Conductivity is affected by the concentration of dissolved ions and water temperature. Next, pH test. The pH before and after the filtration remain the same at 8. The apparatus is a pH paper. pH paper is coated with an indicator that will change color based on the presence of OH- ions or H+ ions. Finally, alkalinity test. The alkalinity is more than 500 mg per liter before and after the filtration. The apparatus used is the same as the apparatus used for the color test, which is the water meter. It is affected by the presence of certain chemicals, including hydroxides, carbonates, and bicarbonates. So conclusion. This is the safe drinking water standards for Singapore. And so this is our results for the sample after the filtration. So from our results, our water sample only meets the turbidity and pH standards. Thus, it cannot be considered drinkable as it does not meet the other requirements for the water standards in Singapore. We also added HOCl into the water in an effort to improve the results. However, only pH improved from 8 to 7. Thus, this does not justify adding HOCl as we would have to use additional resources and time to carry out the filtration.
This marks the end of our presentation. Thank you for listening.